Hey, Algebra 2. Here is numbers 8 through 10, which we're going to do together because they share a Venn diagram. So it says, 5 years after 650 high school seniors graduated, 400 had a college degree, and 310 were married. Half of the students with a college degree were married. So right there we know that this has to be a Venn diagram because there's some overlap. There's two ways we know that there's overlap. One of the ways is because there's 650 students, and 400 of them had a college degree, 310 were married, which means these are not mutually exclusive because these add up to more than 650. The other piece of information we have is that half of the students with a college degree were married. That means there's some people who were in both categories. So let's set up our Venn diagram. Alright, so here's our two categories. We have those who have a college degree and those who are married. And then there's, of course, this group, the purple group in the middle, that are both. We always start with the middle. We have to find out how much overlap there is. So we read this part that says half of the students with a college degree were married. Okay, well, how many people had a college degree? It says here, whoops, it says 400. So we know, since half of that is 200, that we know we have to put 200 here, 200 people. No, I'm not putting it as a decimal form. We'll put decimal forms at the end when it asks us what the probability is. So that means since there were a total of 400 college students, that means that this whole circle here needs to add up to 400. So this category here has to be 200 as well. So that adds up to 400. This one has to be 310 because it says there were 310 people who were married after 5 years. And so we have to make sure that this is 110. Finally, we have to include the category that is neither of these groups. So if we add these, 200 plus 200 plus 110, this is 200 plus 200 is 400, 510 people, which means there's an additional 110 people who graduated who are not married and don't have a college degree. So that's going to be 140 right there. Now we can solve each of these problems really easily. Alright, number 8 says, what's the probability the student has a college degree or is married? Well, that's all of these people. That have a college degree, is married, or both. Remember, anytime we have or, it also includes the people who are both. So, that's 510 people. So 510 out of 650 is 0.78, approximately 0.785. So that's the answer to the first one, to number 8. So then the next one, it says, what's the probability that a student has a college degree or is not married? Okay, so we have to find all the people who have a college degree. Okay, well, these people have a college degree, so that's 400 people. Or is not married. Well, these people here are the only other people we haven't already counted. We can never count people twice. So these people we've already counted that don't have who aren't married. But these people also aren't married, so we have to count them too. So it adds up to 200, 400, 540 people, and 540 out of the total of 650 students is 0.831 approximately. So we say 0.831. Finally, it says, what is the probability that a student does not have a college degree or is married? Now, technically the answer in the book for this is it is incorrect based on the grammar here, so we'll use the correct answer, not the answer the book has. It says, what's the probability that a student does not have a college degree or is married? So who does not have a college degree? Well, these people don't have a college degree, and these people don't have a college degree. Okay, say or is married. So that means we also have to include anybody who's married. These people are married, even though they also have a college degree. We got to just treat these two things separately and just make sure we don't double count anybody. And so that adds up to 200 plus 110, that's 310, 410, 450. So 450 out of 650 is 0.692 for that one. And those are our three answers.